Okay. There we go, there we go, there we go. Holy shit, my mic was muted. Fuck. Alright, alright. Yo, what's up? Controversial rent-free boat living in the Bay Area. Alright, hold up, what's up? Hey, this looks kind of cool, actually. I'm not gonna lie. How's Uber doing? How's Uber doing business-wise? I think you can read for yourself if you know. If you look at the 10K and you can read financial statements, I think you can read it for yourself. I'd rather not say anything that would that might get me in trouble with my employer. But I think if you can read it, you can understand. Yo, what up? Okay, I see people are starting to pour in here. People who live on boats. This is actually is kind of cool. I'm not gonna lie, but on Sausalito, yeah. Currently at a startup as an intern. I graduate in the fall this year. Any advice? Um, yeah, man. I would say just apply, get good at coding, and swing for the and get a job, man. And if you can't do that, then definitely try to at least do some projects that you think are going to be meaningful. That's my best advice to you. Yeah, even doing your own business is also pretty good. I did contract development for a while, and starting that is actually it's a pretty easy way to make some pretty easy money. I think. I would say at minimum, if you're working like that, you should be charging 5,000 a month at minimum, because that's basically your living expenses, especially in the Bay Area. So contract development is always a great option, but just make sure you're paid. And you might be living paycheck to paycheck for a while actually. But I think that's like the worst case scenario in case you don't get a job. Do I coach for object oriented programming? Yeah. The 2 hour coaching session is just for whatever we need. And in some cases, it will be for object oriented programming. I believe that's going to be the case for the L3 loop, especially if you're a new grad. So, yeah, get good at that, man. Yeah, so if you want to get coached on that, just sign up on my website or feel free to send me a message. You've been there for 2 years and your boss wants you to take full time when you graduate. Well, if it's a company that you think you will learn a lot at, that you have other people that you can rely upon and really learn from, and as long as the pay covers your basic living expenses and you have enough to saved over, I think that's really the that's really it. Like you don't need to swing for the fences for a salary at this point in your career. What you really need is really good people to learn from. Mm, Spotify deletes 70 Joe Rogan episodes. Didn't he have like a contract with them? That's like a really good way to like burn your contract. What the fuck? Oh, how we automate our complex product screenshots. Oh, that's cool. This is cool. Selenium. All right, to verify test modes. Front end framework. So they have a new test management tool. All right, cool. Let's see how this works. Actually, I think this could be really interesting. Okay, so then they generate the tests. Ah, cool. All right, all right. Okay, so they just basically have all these different stuff coming in, and then they just kind of they show you a PNG of it. It's just 60 lines. Try, yeah, kind of consuming to actually do all this shit yourself. That's correct. Is my net worth over $1 million? I'm not gonna say, man. Whatever my engineer, you should be judging me on my engineering skill because that's kind of like what most of my content is geared towards. I don't think my net worth should have any impact on that. So, for all intents and purposes, just assume I'm a homeless bum living in my mom's basement. You know what? You know what? That's gonna be my answer from now on. I am a homeless neckbeard living in my mom's basement, watching anime all day, and that I'm worth $0. Let's use that answer, okay? Bump, in yesterday's stream, you talked about mechanics matter. Okay, in yesterday's stream, I talked about that mechanics matter. So let me elaborate on that. Yeah, okay. So what I mean by that is that for things that are your bread and butter, and let me actually adjust my camera. Hold up. There we go. So what I mean by mechanics matter is that you should still be, no matter what level you're at, you should still always be able to debug your code. You should be able to dive through multiple layers of the stack. You should always be able to like identify patterns, coding patterns that will help you along the way. Like you should understand singleton pattern, especially builder, command, strategy, facade, all these different patterns. Those mechanics never die. But most importantly, your ability to solve problems and to really go through each and every single possibility of why something doesn't work and to really test your code, to really be able to do all that shit of what's required as an engineer, that never changes. And the stronger you get on that, the more runway your career has, because when you start dealing with more complex projects, these details are what kill your projects, because they are the ones that will hinder you from making progress, from meeting your deadlines. And so the better you get at going through the details and anticipating what can screw you over, that experience compounds on itself, and you'll be able to reference that later on in your career. I think I'm giving you like a few examples of me fucking up in my career, where it's like, oh yeah, I designed like the player's a finite state machine. I didn't test enough. I did XYZ. And then just by simply like burning myself on those mistakes and understanding how much time it costs, I got better at estimating. It's like, okay, well, testing this, if I don't manually, takes me an additional like 4 hour, like, additional like 30% overhead time, because each time I make a commit, I need to do a test for it. So 30% of my time needs to go to testing, based on my past experience. Other times would be like, oh, I need to plan this. If I don't plan this, then I easily lose track of like 20% of my shit. And not only that, the code that comes out is just subpar. So having been through all that experience, I have a pretty good estimation and instinct of like, if I cut this corner, this is going to cost me this amount of time. And I don't know this. Therefore, I'm going to try asking myself these questions so I can avoid this situation. It goes back to the idea of where am I going to, it's like, where am I going to die? And what can I do to never go there? That's it. And so the way you really save yourself is by getting good at these mechanics, knowing how to solve them, and knowing what mechanics you can use to get around them to begin with. Do I think a recent college grad working from home is common? Yeah, I think so, at least today. The reason why is because, COVID and all that. It's like, most people graduating today are basically onboarding remotely to other companies. And so a lot of at least from what I've seen, a lot of people have known nothing but work from home. So it's not even that uncommon, I think. Optimizing screenshots from code. We should want our screenshots to convey main benefits and features of our app, so we fine-tune the content and automatically add placeholder overlays. Sure. You've likely noticed place text holders and screenshot sites. Yeah. Small gray bars. Okay, leave out unnecessary details. That'd be irrelevant. Sure. Usually placeholders added by designers manually into the app. We can apply a CSS class to show what the place. Okay. Yeah, we don't often want to include the whole nav or nav. Instead of manually cropping screenshots, we get the position size of a DOM element via JavaScript. Okay, I see what they're doing. So they're basically like rendering the screenshot as like basically an XML or their code equivalent, and then they end up like passing that in. And so basically, I think this is a pretty common pattern. The reason why is because what you end up with is that this can actually be rendered as a string, and then all you do is just diff the string. It's pretty nice. All right, looks like it's 11 a.m. Let's go ahead. Yo, hello?
Hello?
Hey, what's up?
What's up? I'm doing good. How about yourself?
Hey, doing good. Yeah. So let me ask. So let me prep the doc. So I'm gonna go over a few questions with you. You said that you had upcoming interview for Facebook and Microsoft, right?
That's right.
Okay, so let me actually share it. And those are going to be in 6 weeks, I believe, right?
Yes. Uh, the recruiter from Microsoft, he just sent me like a doc for me to put like an interview date. That is better for me.
Okay.
I put like for the phone screen. I mean, for the first week of March, I put it.
You put what?
And first week of March, but since we're talking about extend this period, I just email him back again, like to extend this period.
Okay.
And the Facebook, she just like sent me the email like with the options of what kind of position do I want to move forward, if it was an internship or a full time. And once I like email she and we can decide the best date for the phone screen. Yeah, that's the picture.
Okay, so I'm gonna say that let's shoot. I want to swing. I think that with you, I think we can go easily for full-time positions. I don't see any point in just having you do a 3-month internship at Facebook.
All right. Okay. I'm considering this.
Okay.
I just respond the email saying that, want to move forward with full time, and like answering all the questions that the recruiter asked to me, like graduation date and things, and like yeah.
Okay, so and I want to, as you say, first week of March, but the February 28th falls on the same week. So what I want to do is I want to actually try to aim for the 11th for now, but depending on how well you do, we might not need the full 11th. So right now let's shoot for that date, but tentatively let's kind of figure out. Let's kind of hope for something sooner. But I think that based on let's see how today's session goes as well. And you mentioned before that your problem right now is conflicting principles, right?
Yes. That's
all right. Do you have an example of a problem that you screwed up on that you think adequately reflects this?
Let me just think. Let me take EPI here.
Yeah. Go ahead. I have the book with me as well, so no problem. I'll go ahead and set up your coaching sheets as well.
What? What did you say?
Your coaching sheets. So you see me do this with R. I'm gonna do it for you too.
Oh, okay. Yeah. Just so I can give you a good example. Okay. I think. Yeah. Okay. There's a problem. My book is Python version, so it's the 519. Okay. Rotate to the array.
Okay.
Right?
Okay. Go ahead.
Yeah. By the way, I tried to solve before watching any of your streams, so I'm gonna just put my what happened to me.
You tried doing what?
I practiced before watch you like solving with the R play the guy. Okay. So what I did, I tried like very clear. All right, let's think about a naive approach. What can be done like not being optimized here? I did it kind of okay. Maybe if we allocate extra array to like copy this and traverse like in some way that I need to figure out, like me thinking with myself, right? And all right, okay, that's one point that I think I was doing wrong, because I was not like deep diving in this naive approach. So I just like mentioned and took a note, right? And didn't detail this, which I think is a problem. And then I like I just made my way to kind of going to like the most optimal approach, the optimized approach. And I from this just saying what I will do when the naive, I start to like doing the most optimal. And I try to think about the details of the problem, like how can I shift like this item for the last, and like to draw a pattern first, right? Like what can be done, and yeah, and yeah, that's like one point, right? As I mentioned. And the other point that I found out that was not so good is that when I finally like draw my idea, basically in theory was right in my head just reading, but when I was like implementing this, I did like as you said, like a giga complicated solution with like a bunch of booleans and yeah, that could have a lot of edge cases that we'll not cover.
Okay.
And yeah, after like spending almost an hour on this problem, I just looked to the answer and read like the line of thought, right, that they put before it gives you the answer, and was like much more simple. If I took like what I think and organized this and think about, okay, I should traverse one direction, then I should go in the other, that will be like the optimized solution. So I can address two problems.
Okay.
Yeah, that's it.
Okay. Try to organize it. Okay, I think I have a good idea of what your problem is. I think it's clearer to me now. Yeah. So I know what to do with you. So let's start. We're gonna start with the basics.
Just asking, is it very bad or? Like,
no, it's not that bad actually. I think it's pretty common. I know what you're doing. Yeah, don't worry too much about it. Let everyone start somewhere. So we're gonna start with the basics. And I'm gonna just show, and I'm pretty sure you know how to do recursion, so at least I don't have to cover that with you. But I'm gonna make you do a recursion problem, and because of like how simple it is, there's gonna be a lot less for us to focus on. But I'm gonna show you something pretty that I think is gonna like actually change the way you see things. So,
all right,
let me actually bust out the timer here, and we're gonna do normal stuff. So, let's see. Okay.
Oh, in the background. Just one thing. Sometimes my dog will bark eventually.
Oh, that's fine.
Anyways, in advance.
Say hi to the dog for me.
Okay.
All right, let me go ahead and bust open this. Okay. All right, so I'm pretty sure you've seen me give this problem out, but I don't really care.
All right.
So. Actually, yeah. I'm gonna see if you can do this. So, all right, I want you to find the kth smallest element in a binary search tree. So, I know you can do this problem, but I want you to show me your step by step.
Okay. Okay, find the kth smallest element in a binary search tree. All right. So. Thing I can think here, yeah, given the fact that is a binary search tree, like the nodes, they follow a specific property, right? So all the nodes in the left, are like less or equal than like the root, the node that I'm at, right? And the node that I'm at are like smaller or greater than, greater or equal than the nodes on the right.
Okay.
So given this property, let me just think. Let me just think about an example so I can walk through this. Given this example you put here, let's say you ask for the third, the third, like smallest one. Basically, the first, my first thought is to do a traversal, right? And store this inside a list.
Okay.
And then later on, after constructing this list, go like in the kth element. So I would find like the smallest element, right? So I'm gonna just take a note here. So for the naive approach,
okay,
traverse the tree in a in order traversal, right? In order traversal, and take the cave element. Yeah, that's it. And output.
Okay.
Basically that.
Sure.
Right. What I can see is that I'm gonna traverse like twice. Given, for example, if like this element here is the last of this tree, right? So in this case, is 7. So it's gonna be the last. So I will have to traverse like to build the list, and then to find the smallest that's gonna be like the greatest in this case. So it's 2 traversals. That's inefficiency, right, that we can see here. So, and in terms of traversal, since we are not doing like repeating work, like while you're traversing the tree, in fact, only like on the results, I see that. Yeah. Also, we can save like time while you're traversing, because in one traversal, I guess that we can, following some sort of order, we can find the cave element.
Okay.
So the inefficiencies that I can find are like there's like 2 traversals,
Okay.
and extra memory being allocated.
Okay.
Thinking about those inefficiencies, basically, just let me think. What can I do? Yeah. All right. We can actually, instead of doing 2 traversals, we can do this in one. All right. So like an optimized approach will be like try to do this in one, and while you're traversing, find the cave element based on some variable. So yeah, while you're traversing the tree, identify what node I am at, and once is the cave, return on like return as a result. Okay, so this will save us like the traversals and the extra memory, because we don't have to allocate one more thing, as I mentioned. All right, being repetitive here. Okay, now let's see how I would do this traversal. All right, following, basically traversing from 15 to 10, and then to 8. Let me just take it. Okay, let's say that the cave element is the cave element is like 2, right? So is the second smallest. In this case, it's gonna be the 10. How I would like stop in the 10? So traversing from 15 to 10, then to 8. Yeah, let me just think a little bit more. I find a way to like why you start to traverse by 8, but this is not gonna be possible.
Wait, you're gonna start at 8?
Yeah, but that's not possible. I just like throwing ideas here.
Okay.
No. Okay, if I traverse from 15 to 10, I can keep track of of like I just traverse 1 and then if I traverse 2, 8.
Mm-hmm.
Okay, just let me do something here. I can have like just like a buffer. Let's see if that's gonna work. So I just put 15.
Sure.
Then 10 and then 8, right? So second smallest here, second smaller is gonna be 10. But yeah, I don't think that it's not gonna result in nothing.
Mm-hmm.
Let me just test if I can see something that I can do here.
Okay.
So if it's the third, no, actually, I'm gonna copy this. If it's the third one, so maybe I traverse from 15 to 10. Maybe there's something like about the how greater is the number I am at, but no, I'm not gonna dive in this. 15 to 10, and I need to go until the 12. That is the third one, but also I don't see, like, I'm just like putting the final result. I'm just going to the final result here. That's not helping me out. Okay. All right. So is there's no like no I was like thinking about this tree as being unbalanced, but that's I think that's not gonna help. Hold up.
Okay.
Basically, I'm thinking like just throwing an idea that I will, like, if I cannot tackle first like the extra memory factor inefficiency.
Okay.
I'm just gonna try to not do the. No, if I cannot do like the, I think I can like solve this problem of the extra memory, but like as I mentioned, this is gonna be if we think about time complexity, because I just got an idea.
Okay.
If at each time I was traversing, I can possibly sort this.
Wait, what do you mean sort? The by definition, binary tree should already be somewhat sorted for you. So.
Oh, yeah, for sure. There's this property. Yeah, that's not. Yeah, it's sorted. Yeah, I just like I was trying to decrease the time complexity here. Yeah.
All right, why don't you do this for me? Try to write out the naive example, actually.
All right.
Just as an exercise, see if you can see if it helps.
All right. So, as it is here, I was gonna do a traverse in a tree in order, and then take the kth element, the list I created. So.
Okay.
It's pretty clear how this is gonna look like, right?
Yep.
So I'm just gonna do like this. Get kth element. We're gonna receive the kth element here, and this is gonna be my elements. Yeah. Those are going to be my elements, and yeah, here it's going to be my traversal.
Okay.
In order. Oh yeah, actually, like just a normal traversal. Yeah, and also I'm going to receive the roots of the tree. As well.
Okay.
Yeah. So And yeah, just basically, I'm just gonna do this traversal, but pretty. Actually, I'm gonna return k minus 1. And now doing this traversal, you can do it like here.
Mm-hmm.
I'm gonna call node here. Not node. If it's nothing, I just return, and then otherwise I'm just going to call my traversal. Just a minute. Node on the left, and the nodes on the right.
Okay.
Nodes on the right, and since I'm gonna have and actually I have to pass this node that I am at. Elements append. That's in the node value here. Let's assume that it's called like this.
Okay.
And yeah.
That's fine.
That's pretty much it.
Okay.
Yeah.
Okay. So go ahead now. Using that, can you try and figure out your optimal solution?
Yeah, I can try for sure. So, all right. I was just thinking. Yeah. Oh yeah. Since it's an how can I was not I was not thinking about this. Anyways, I think that while I'm like creating this list, right? I know, like, I'm just gonna try to see if something happens here. I'm just gonna run this for this example. All right, so actually, this is not gonna be an order traversal. I'm gonna put the 15, the 10, and the 8. The 15. Okay. And the 10 and the 8. Yeah, that's wrong. If I do this right here, like, just a moment. Here, let me see something. So basically, on my call stack, I'm gonna be on the 15, right? And I'm gonna call this node, and like this is my list. My elements list.
Okay.
So it's still empty, and then I'm gonna go up on the call stack. Oh, actually, and this is gonna be right, and my list is still empty, and then my node 8.
Okay. Wait, are you doing you're doing your what's called your naive solution? But why are you doing this call stack thing?
Just to see. Yes, because I'm not sure if I'm implementing this energy traversal the right way. So yeah, once I try to go down, there is nothing more I can explore. Then I would return, and then I try left, nothing to explore. Okay, and then here I'm gonna append my 8. And then this is gonna be 8 as well as here.
Okay.
Then I'll go back in the call stack. Yeah, then 10. All right. I think since and then once I'm in the 10, okay. I think I'm just arriving the final solution. I'll go in the 12. And same thing. I'll just try to explore both sides. nothing there, and then I'll put the 12 on the list, and this is gonna be the 12.
Mm-hmm.
All right. Okay. I am thinking, yeah, based on the size of the list, I can like actually yeah, one optimization here just to not like allocate another list is like to check if the size of my list is the same size of
I
like,
would
the
argue
cave,
that
so
with the way you set this up right now is
uh,
not a in order traversal at all. I think you're assuming like a straight line for your tree, so I think that's why you got the answer that you did. But can you see why?
okay. Maybe no, let me just actually think about before saying. Um, um, maybe I was thinking about this tree being unbalanced, but
Yeah, that's why I mean your tree was unbalanced. That's why you got the answer. But your answer is your the way you wrote this out is completely incorrect anyway.
um, no, I mean like this is working just for a balanced tree and not working for an unbalanced tree.
I don't think so.
Um, let me just. Oh, actually, yeah. Let me just think a little bit. If I um, did this right here, what I'm gonna be doing is I'm not gonna do the call stack thing. All right. So
Okay.
the first node is gonna be the 15,
Okay.
then 10, 8.
So wait, what are you draw? Are you saying that your what does your tree look like? 8, like 10, and then 15? Is that what you're trying to do here?
Can you just repeat, please?
What does your tree look like? Is it looks like this that I've drawn out, or what are you doing?
No, the same tree. The same tree.
Oh, same tree that I okay.
Yeah.
Yeah, but then
So
8, 10, if you only look at 8, 10, 15, that's an imbalanced tree. That's completely skinny to the left side. Why not try doing it on 10, 15, 20, just as a happy case first?
Okay, good. All right, so yeah, that you're right. So let me just check. 15, 15. Sorry about that. 15, 10, and 20. All right.
Mm-hmm.
All right. So yeah, if I figure out this case, I can solve the others. So yeah, I'll gonna first put the 15 and then the 10. Then I'll go back on backtracking and then 20.
Okay.
Yeah, that's not gonna be an order traversal. Yeah, and now, yeah, if I do like this, let me just check. Okay, 15. I'm in the 15. It's not a pendant, nothing. Then I'm in the 10. All right, and then I'll try to go left. And then I'll put 10, right? And then I'll go up on the call stack and put 15, and then visit my right node, and then put the 20. Yeah, that's the right in order traversal actually.
Okay.
Yeah. So basically, following this, I think now it's correct, like the in order traversal. But as I mentioned before, when the length of this list is equal to the k, I can stop and just set this as the result, right?
Sure.
So, but here's the thing. I believe that there's one more optimization that can be done because I totally shared that I don't need this list, right? And let me just think here. Well, actually, instead of append here, I just need to like keep track of which element I know. Since this is a binary search tree, I know that it's sorted. I think I'm gonna do like that.
Mm-hmm.
So, like, I'm gonna put order, right? And I will increment here.
Okay.
And if order, oh, yeah, capitalizing. Order is equal to.
Don't worry about
equal to
capitalizing.
K.
I know what you're doing, so.
Yeah, if order is equal to K, I'll just go into, yeah, I can break right here, and yeah, result is equal to the node
Okay.
value.
Mm-hmm.
And yeah, just let me declare this, and this is gonna be the result.
I want you to actually return the node itself.
Oh, the node.
I mean, it's fine either way, but I think it'd be easier for you if you return the node. So.
Right. Yeah, let me just. I'm just thinking now about. Sure I can return this right here, but I'm just thinking in the case that I know that's wrong because if I found my value and returned here, there's nothing I can do. So, yeah.
Okay.
Oh. Okay. 8, 10, and what can I do? Let's say that is the 10.
Mm-hmm.
Yeah, I'll just going to. Yeah, start this as none.
Okay.
And do a result here. Just taking this. And no, actually, sorry. Result. And in case that this is different than none, I can. In case that this is different than none, I can. Actually.
Okay.
Yeah, in case it's different than none, I can return it.
So then, okay. But then what about, you said you're returning no dot, okay. Alright.
Yeah, so.
I see what you're doing.
For example, if I. Huh?
I see what you're doing. Yeah, go ahead.
No, yeah, I'm just figuring out how to do this in a better way. Yeah. If it's different than none, I will return result. Yeah. Yep, I'm just sure that this is gonna work. Yeah. Result is different than none. I just have to return it. Oh, yeah, actually, it's set here. I just need to return whatever it returns on the call stacks. So I just have to return the result. Yeah, because once this is, it's assigned here. It's gonna be like returning on the call stack. So, yeah. Do you want me to do a test to see if that works?
Okay. Yeah. So I it works. Yeah. And you can try walking through it, but I think you can make there's some optimization that you can make for it.
Okay. Would you like me to go for a test or to
Yeah,
have the
watch.
optimization?
It's up to you if you feel confident in this or not. Yeah.
Yeah, I think I'm pretty sure that this work, right? I
Mm-hmm.
can do like a quick test since this tree is like very small.
Okay.
So let's say this is the call stack. Uh, and we are in the, let's say that this first is the node, and yeah, the other is
Mm-hmm.
the result. Okay. Um, First, I'm on the node 15, then go to 10 and 8.
Mm-hmm.
All right. But actually, I need to keep track of this order I'm not declaring here. Order is equal to 0. Yeah. Okay, then this is the order. Okay, now yeah, once I am in the 8th node, I'm gonna increment this, so this is gonna be 1, right?
Mm-hmm.
Yeah, actually, I'm gonna be here in node 15, and then on the 10,
Mm-hmm.
and then on the 8.
Mm-hmm.
And this order is gonna come on like the call stack being, let's just put like the case is the 3 we're trying to find.
Okay.
And yeah, and I'll be this first in the 15 is 1, then on the 8 this is gonna be then 2, then 3. All right, so here I found my node, right?
Okay. You're looking for the your K third smallest. You're saying 8 is your third smallest element.
um, yes, no, yeah, I was meaning this, but it's
I
not
think you might have
right.
done the stack trace wrong, just to let you know. So.
Okay, yeah. Yeah, actually, you're right. 8 and 12. Yeah, I did this wrong. So yeah, yeah, totally. Yeah, this is like start with 0, and then this is gonna increment on 8 because this is the smallest. And once I go into 10, this is gonna be incremented, right? And I haven't found my result yet. I was wrong. And then I'll go to the 12. That is the third. All right. On the 12, I found like what I need. That is the order being the third one.
Okay.
And then this result's gonna be set it as like 12, right?
Okay.
And then this is gonna be returned on the call stack
Sure. Okay.
for this and for this. Yeah.
Okay, so it's gonna return on the call stack. Wait, are you sure? Wait, close. Hold up. All right. So you have 15. So you have 12. Yep. So 10 will return the call stack. Yep. And now you're at 15, right?
Yeah, it's gonna return to the 15.
All right. Then what happens after that?
I'm gonna try. Oh yeah, the optimization. I think following that, I'm gonna traverse the right hand side, but yeah, I don't need this actually. I just need to stop.
Okay. So then what should you do?
I just need to think. I just need to like check if I found like a valid result, meaning that it's different than none. So what I do is at every single node, I check if I found something. If so, I can. Yeah, I'm just trying to eliminate this portion here. Yeah, once I go back on the call stack, I'll try the other side. But what can prevent me to do this?
Yep.
Oh yeah, if I do I'm just a little bit confused. I don't know if I break this here.
Why would you break before you return?
Oh yeah, I'm just trying to break the recursion actually. No, not the return. I meant, yeah, but this is not gonna work. I was trying to figure out how to break the recursion here.
Okay.
So it can prevent me to traverse the other part.
Okay, so let's think about it conceptually instead of trying to do it mechanically, instead of trying to do it with code. So, you don't want to go in to that traversal if you found the result.
Yeah, that's right.
So how would you express that in code?
I think... Oh, yeah. Since this is the part that I will traverse right, I can cut this. And by cutting, I mean, I just... if, like, the result here on the node left, right, returns me a valid result, yeah, I can cut this to not go in the right here.
Sure.
So if result is different than none, you just can return the result, actually. So this is going to prevent me to... Yeah,
I mean, you're only going to return results, so this is like a few extra lines. So what else could you do to make it a little bit, a little bit cleaner on the code front?
Let me just analyze. Yeah, I'm actually returning the result. I think... let me just... I think I can do... No, I just worry if that's gonna work.
It's very simple, actually. It's very simple. Don't overthink it. Very simple.
Okay.
It's just a cosmetic change in the code. I'm gonna give you like 10. I'm gonna give you 15 seconds, and I'll tell you. And after that, we'll go over what your stuff.
All right. Yeah, that's not right. Actually, but yeah.
Okay, you know what? You're focused on the wrong thing. All right, I'll tell it to you. So let me undo. So all you really need to do is, if the result equals none, return traversal, and then otherwise return result. That's it. It was just an inversion of what you had before. Do you understand why?
Yeah, because if it's equal to none, I should like to try to find the case because I haven't found yet.
Exactly.
And if it's not, it means that it's something, I found something, then I return the result and then go to the right-hand side.
Yeah. So, I know what your problem is. So let's talk a little bit about it. You got the answer, but it took you 36 minutes. So let's talk about what you did right and what you did wrong. I want you to do like a little bit of self-analysis here and tell me what you think.
Okay. I'm just gonna analyze here. First of all, I think it was bad. I messed it up on the part of the traversal. First, I just put some code without thinking, right? I just trying to hope if that works without really thinking. Without thinking, conceptually, and then converting this to code. I think that was one bad point.
Okay.
And I'm just gonna address that. I think that is an issue, that it really is a problem. Sometimes I get nervous. All right, that really is a bad thing as well. I need to be like calm and yeah, let's see, go methodically, right? In a method, following a method.
Okay. Anything else?
That's another point.
Okay.
And let me see if I found something else. Yeah, and sometimes those inefficiencies of like not figuring out this thing you showed me.
Mm-hmm.
I think those are the points, basically.
Okay, I'm gonna say your problem is so much more simpler than that. Is that you don't understand the problem conceptually in your own head. You just try to outthink it, and I'm honestly quite surprised that you were even able to get the answer actually. So this tells me at least you have some intuition. But the bigger problem is that, like, if like, let's take this small microcosm example before I dive into the notes, like this one. All you have to do, and conceptually, all we're doing is we're traversing to the left, and we're traversing all the nodes, right? And each time we traverse, we increment the counter. And if our counter, like, if we match, and our counter matches to what we're looking for, we just return the node. But then the optimization is that if I've already found the answer, I don't need to traverse anywhere else. So which means that if my answer, I still haven't had anything, then I still need to execute. That's it. You notice how, like, in plain English I described that? And I think that's what you did in your head, but you just never translated that. And the reason why is, I think, is that you've never drawn it out. You don't know how to, you haven't visualized it. And the one big thing I noticed is that you were so quick to just, like, keep doing it in your head over and over and over again, and you came with the idea, but you never fully understood the idea because you never actually tried getting hands-on with it. And because you never got hands-on with it, you kind of meandered around, and you got really confused. It was, like, until I made you actually try writing out the code for it, that you actually kind of said, oh yeah, well, this is actually how it's supposed to work. I mean, you kind of screwed up on the in-order traversal as well. Like, you remember that?
Yeah.
Yeah, like, you straight up just added, like, traversal, left, right, and then added the evaluation step somewhere random. So this kind of tells me that you're not mechanically strong with that pattern, at the very least. It's like the recursive traversal should be bread and butter. It should roll off your tongue. You should be able to write it out. Like, I remember what I said in the guide, and I've said this before, that for shit like this, you need to be able to write this out off the top of your head. I need to wake you up at 3 a.m. and ask you what an in-order traversal looks like. You should write it out immediately and then go back to bed,
Yeah, second nature, yeah.
Exactly, and you haven't hit that point yet. You're still trying to actively think about it. So let me paste my notes here, and then we can talk about it. So, first things first, so you list out the properties of the binary search tree. That was kind of a big, why do you need to list this out? You should know this one immediately. So this kind of clued me into the fact that you weren't really strong mechanically with this. So then you figure out the naive solution to traversals. I thought, okay, well, you could just, you only need one traversal, but then you're storing extra memory, because you can just access the element at k, and that's a constant time lookup. Inefficiencies, you list them out, which is good. You see the optimal, which is good. But the big one I noticed, like, about 6 minutes in, like between 5 to 7 minutes in, is you're doing examples in your head. And I knew that this was going to kill you. Like, in the first 5 minutes, I knew what was going to kill you. And then it's like, and then after that, everything else here is just a consequence of that. You realize, like, when you're trying to test it, all you did was use an imbalanced tree, or just the left side of the tree. And that's why, remember what I said, oh yeah, why don't you try using, like, a normal happy case instead of, like, your weird case beforehand. So I say try with a normal case. Okay. And then you jump to the call. Sorry, go ahead.
I know. This normal case is the one of, like, just 3 nodes, right?
Yep. The left, right, in the middle.
All right. Okay.
Yeah, so basically, okay, so, so jump to the call stack, maybe draw your solution out and what you expect, yeah. You don't know what you're implementing so this just is the inward traversal thing. I would say you're, like, I know here you're not comfortable with your appendix mechanically, because this is like 10 minutes lost trying to do the naive solution, which it in the end was just a normal inward traversal solution, right?
Yeah.
So you took 10 minutes to verify an in-order traversal when you should have been very strong with it. And so after that, you kind of just meandered around, but it goes back to drawing it out. So let me show you how I would have done the problem. So let's say I was given this problem, right?
Okay.
You told me-
Excuse me, I think the call is cutting.
Okay.
If you said something.
Hello?
Hello.
I can
Yeah,
hear you.
Hear perfect.
Good. All right. So let me show you how I would have done the problem, and I think that you should try to copy this as well. So let's say I'm given the kth smallest element, right?
Yes.
So then I would do the exact same thing you did, like try to start off, try to figure out like what is my expectation. So let's say I did the third smallest, right? All this, it would be 12, right? So then I would have done exactly the same thing. Try to do the naive solution. Do the like say, oh yeah, well I'm going to just sort an array to the element at k, and then acknowledge all that. Your first 5 minutes were relatively clean. Then after that, I would have just tried drawing out like, okay, well what can I do? So then I would do something like this, like so. Let's say 10, 15, and then 20, right? I would have drawn that shit out immediately. It's like, okay, well, I'm gonna have this idea like, well, I know that my inefficiency is that I am effectively doing, like you said, 2 traversals. So let's say I want to keep track of k, right? And then when k increment when k is when increment, let's say counter when we visit, and then if counter equals k, we return the node, right?
Yes.
So
Yep.
that's it. So so then once I have that idea, I'm going to actually walk through my example. I'm going to draw it out and I'm going to test it. So not just do the stack trace, but I'm not in my head, which is what you're doing. I'm going to draw it out. So at each point, I'm going to say the general idea is that I'm going to look in the left side. Actually, let's do this. The general idea, x, y, and z. The general idea is that I'm going to go into, it's either in the exists in left side, exists in right side, or is equal to y. So then that means that whatever I do, I'm expecting that when I go to do my recursion, I expect that if I found it in each side, I will return back that node. So if I found it left side, I'm going to return back the node and say, hey, that's my result. Boom, we're done, right? Or right side, boom, we're done. I return back whatever the result is. And if I didn't find it, if not found, return null. So that's basically what I'm going to define my recursion is going to be, right? So now I'm going to do actually your what's called your 15, 10, and 12. 20, right? So let's run through that example, right? So let's say I'm at 15. I'm at 15. My k is equal to 3, counter equal to 0, and then I'm at 15, right? So now I'm gonna be like, okay, well, I'm gonna increment my count. I'm gonna say, let's go into the left side, right? We're gonna go counter equal to 10, left hand side, right? And then, okay, well, then we're gonna have 8 and 12 here, right?
Yes.
So then I'm going to do counter is equal to, so I'm going to say I'm in 8, counter equal to 0. I'm going to go at 8. 8 is a node, so I'm going to increment my counter plus plus. And actually I'm going to keep, for sake of simplicity, let's keep the counter outside the stack trace and keep it as a common variable. But of course we can be a lot more creative with this if we want later on. So let's say we're doing this, right? So my counter's now 1. But it's not equal, but it's not the third smallest, right? I can do my left-hand side. Left-hand side, no, because it's null. 8, counter 1. All right, so, but it's not equal to 3. Let's go to right-hand side. Right-hand side is now, right-hand side is null. We're not going to do anything. Boom, we go back up the stack trace, right? Now 10, we're going to evaluate 10, counter 2. And then we're going to go to right-hand side because it's not equal to k, right? And so now I'm at 12, right? 12, we're going to start with the left-hand side. Left-hand side is null. Null, nothing. Increment counter to 3. 3. And then now my node is 12, right? Because these match.
Yes.
And so now I'm going to start returning back here. Return back here. So I know my answer now is going to be 12. Which is 12. And so now it's like, oh, well, I found my answer. I don't do any more traversals. I'm going to return my result. Equals to 12. And then if, after that, I can always do my check. But check is like relatively small time. So then now I'm going to just return back 12. So you see here, the only difference between what you did and what I did is the fact that I just like drew it out and did the stack trace. You did the stack trace in your head. I just kind of drew it out. Does that kind of make sense?
Yeah, for sure. For sure.
Yeah. So in order to make, I know it looks very similar, but there's a very subtle difference here. It's that I just actually like looked at it, and then just took pen to paper, or in this case, keyboard, typed it out. So let's compare like what you did here. Like I feel like you kind of skipped some steps here, and you just kind of did it in your head. So like this let's look at this here.
Okay.
So you said solve stack 15, order result 12, right? But you didn't really know what you wanted to do with it either. So let's point back. So what is that subtle difference? Like you can do stack trace. I agree. The thing is that you didn't actually walk your problem through the actual image or the actual example. That's what I think it is.
Do you mean like before coding up like the naive approach? Like,
Correct.
I have an idea and then test it out as you did, right?
Yeah, exactly.
That's the point.
Exactly. Like, okay, well, you say you're going to iterate, you're going to do the kth element, and then you're just going to be like, and it's going to work. But you never really walked through the example itself. So this is what I mean when I say draw things out, I literally mean draw it out. And I suspect that this is what happened with your, your rotated 2D array. You never actually tried drawing out what exactly it looks like, so you never made that conceptual connection.
I did, but I complicated a lot my solution. I did like the same thing as I did in the end. I put like a if where it doesn't need,
Yeah.
So on that question I focus on draw, like know where the shifts were happening before like draw any code it up.
Okay, but then like the shifts are happening, but then you need to be able to assemble it into like a nice picture, a nice story. That's what I call it. It's like it's like it's not so much that let's say you're described walking to someone, right? It's like okay, you put your left foot in front of your right foot, then you move, then you push off with your right foot, and then you move using that push, you move your momentum forward, and then you move your right leg in front of your left, right? That's essentially what you've done with your code here. And and instead of calling it walking, each time you imagine if like you were having a conversation and you described walking that way every single time. So instead of saying walking, you just said I move my body forward as I move my left foot in front of my right. That's essentially the equivalent of what you're doing here. And the reason why I say that is because you're describing all these mechanical movements, but you haven't like connected it to the big picture.
I see.
Does that sound pretty familiar?
Yes. I was just, even though I was kind of testing this call stack, I was thinking about the code actually, not about like the idea itself, right?
Yes.
Is that correct?
It's like I want you think back to the problems that you did. Were you thinking about how the code looked like, or how the problem flowed, or how the step by step was in your head image wise?
Being honest, like a few steps I think about the idea first, but then I try to match this idea to like what the possible code gonna look like. I think that's like the pattern that I'm following.
Okay, I would say you might be jumping some steps. You might be like jumping to the code before you have a full idea. Do you think that might be
Sorry.
it?
Can you repeat? Once again, my internet just broke.
That's fine. Do you think you're jumping to the code before you have a full understanding of the idea?
No. This I don't do this.
Okay.
I think I was like doing the idea, but the I think not connecting the dots. This thing, for sure, I can guarantee you. I just did like I just write a few lines here on the naive approach, but I acknowledge that I didn't like put a lot of details into how can be my possible solution.
Okay.
This time, but I try to do this every time, being honest here.
Okay, that's fine. So what I want to do, I want you to use this tool. Before you go into a problem, I want you to test it visually. What does each step look like? What does each step entail? For instance, like if I go into 15 to 10, like I should be able to see that visually and then understand that, okay, that means that when I do that recursion, I'm literally calling recurse on this node. Right? And then define what I get back out. So it's being a little bit more thorough with it and running through your example, and not only that, trying to look out for what can kill you.
All right. I have one question.
Yes.
For example, I watch you like solving, but it seems to me like that you already have an idea how to do this. But for example, when you don't have no idea, do you recommend like try to, all right, first have a small case as you did, like 10, 15, 20?
Yep.
Like testing an idea just on your head.
If
Just
I
testing
okay.
on your head and like writing down the results and then taking the steps, right, that it's gonna work, or try to think about the steps that would work and then test as proof it. You know what I mean? I don't know if I express.
I think I know what you mean. It's like, do you want to test it before you put it down, or do I want to put it down and then test?
Yeah, basically that. Yeah.
I would always write it down first because I can't do problems in my head. I'm going to tell you this. I know people who can. I am not one of them. I am not smart enough to do that. So if I have an idea in my head, I'm going to draw that shit out. And then, like, so I can say it's on paper. And once that act of, like, drawing it out and working through it on pencil and paper, it's like, that gives me better understanding. I'm not smart enough to do things in my head. And I don't think a lot of people should either. And you know what? If you could, then you probably wouldn't have this problem either. So I'm going to say, draw it out, and then once you draw it out, then then test it. Like, hey, it's like the scientific method, right? I have a hypothesis, or engineering. I have some hypothesis. I'm going to do some test code. I'm going to try it out, and then it seems to work. Now let's bash it against the pavement. Let's see how well it holds up. I'm going to give it a chance to try and breathe before I completely destroy it and test it.
All right. Yeah, that makes sense.
So I want you to do the same thing. Like, if you have like an idea of how this works, I want you to draw it out the same way I did. Like, just like, walk through it generally, like with that XYZ I did, and then try to walk through it like step by step visually with the image. I know it's kind of hard on Google Docs, but I still think the act of like writing out the way I did, like I did, like the 10, 15, and 12 or whatever, right?
Yeah.
Yeah, I wrote that out. And I would suggest you do the same thing before you commit yourself to code.
All right.
And in fact, like I would recommend, like if you want to, and I think you should, do the pseudocode for it.
Okay. I'll do it. And then I can test this again. And one thing you did that really facilitate, I guess, you like just reduce the test case so it don't be so overwhelming in terms of like testing your idea.
Right. So basically, the idea with reducing a test case is making sure that you represent every single possible scenario. And to me, you haven't really done that yet, so don't worry about it. I want you to focus on these two mechanics. I want you to focus on drawing things out, so that way, like before you go commit to it. And the second is, I want you to at least try the pseudocode. I know, like I said in the past, pseudocode is a crutch, but right now I think you're at a point where you need to be able to translate that drawing into code. So of course you can eliminate it later on down the road, but at least for now, just do it for the sake of getting better.
Okay, we'll do it.
Okay, so let's give you another problem. Actually, let me get a drink really for a sec.
All right.
Okay, I'm back. Okay.
Hello?
Yo, hello?
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 I can hear you.
Yeah, I can hear you. Can you hear me?
Yep.
All right. And then I want to add one more note here. It's like, where am I going to die? Or, like, where's my code going to die, I should say.
On the after the pseudo code.
Yeah.
All right. Trying to find like where it's gonna die.
Uh-huh.
Okay.
Yeah, where's my code going to die? And so it So avoid that or handle it. I would most likely say like make sure that you handle it. So these are where you say the code's going to die, like all the situations that are going to make it crash. How can my code crash? You know, so that's basically what I want you to keep in mind when you're testing these things. So I'm not gonna time you on this. I want you to practice like these ideas that I've mentioned. So.
Okay.
All right. Given a binary tree, find the lowest common ancestor of two given nodes.
Okay. I'm gonna put in the other page. All right. By lowest common ancestor, it's like, for example, if I have, given a binary tree, find the lowest common ancestor of two given nodes in the tree. All right, so basically you're gonna give me two random nodes. Let's say that is 6 and 0, and I should give you like the low common ancestor. That in this case, the only connection between in common between 6 and 0 is gonna be 3. All right, and then in the case it's like 6 and 2. The lowest common ancestor for me, it's gonna be the 5 because they're close. It's close. All right. So basically, given that definition here, let me just start to draw my ideas out and walk through it. Basically, let me just take one example that I think it's good as well to make sure that it will work. So if you gave me the 5 and 4, in this case I should return you the 5, right?
So if you gave me 5, yeah. So 5 and 4, you should give me 5. Correct. Good catch on that.
Right. That's a corner case, I guess.
Yeah, that's a very good catch.
Yeah. Let's first try for 6 and 0, and let's see what ideas I can have about this. Alright, so given the 6 and 0, basically, well, the first thing I can think here is, okay, thinking about the idea that one node is the ancestor of another, right?
Okay.
I can think about like this ancestor node.
Okay.
Being like, I'll put like this 2 check marks being checked. That's.
What do you mean 2 check marks?
For example, I think that was not so good. No, let me just do it again.
Yeah.
Right. Basically, I can traverse, like, let's say I am in the root node, then I'll move to the 5, right? And then I'll go to the 6.
Okay.
All right, let me see what happened if I found one of the nodes that were given. All right, basically I can mark that I found one of my nodes, right?
Okay.
All right, so like found. And
Wait. You don't. The thing is that. Oh, okay. I see. So you found one of the nodes. All right.
Yeah. But okay, and then okay, and then what I'm gonna do is try to search in the tree if I found like another node. All right, so I will go into so basically I can give this that I found 6 here. right? And then I can try on the right hand side. All right, so let's try to go deep in the 2, in the 7. Nothing found here. Nothing is matched with 0. Then I'll go back. All right. And what I can think here is, all right, given that I just found the 6, I need to find the 0. I mean, I'll go into my call stack, right? So I'm gonna go into the 1 and into the 0. Oops, I found it. So I found the 0. So I can return this to here. And once again, we have a situation here where I don't need to explore like the right hand side portion.
Okay, I'm going to put a quick pause on you right now. By the way, I want to point out one thing that you are doing essentially an order traversal, and you kind of declared yourself to do it. And I want you to actually think a little bit more generally, because it doesn't really matter if you do pre-order, post-order, in-order traversal, right? The key that you want to really focus on is whether or not you've found the nodes. But then, are you finding your nodes in the left subtree or the right subtree? Does that make sense?
Can you just like repeat, please?
So
that doesn't make sense for me. Yeah.
Okay, you know what? How about this? Progress a little bit more through the problem. Ignore me for now, and then maybe it'll make sense once you get to a point.
All right.
I'll repeat myself when I think is a good moment. So yeah, keep going.
Okay. All right, and yeah, maybe I don't need to check like the other. What I mean by this is that okay, I found the 6, right? I was trying to, yeah, on the left hand side. So my right hand side, there's nothing. Like, I haven't found nothing.
Mm-hmm.
And yeah, let's do the same thing here, but like inverted.
Okay.
No, yeah. And once I am like in the node, and then I will be in this 1, and then return the result of the call stack to the 3.
Oh.
In the 3, this is gonna be like checked.
Okay.
Right? And yeah, once this is checked, I know that this is the only node where I found something on the left hand side and then the right hand side.
Okay.
So, okay. Yeah, I just wanted to check if this is gonna work for the third example here, because it's a little bit more tricky, I guess.
Yep.
So let's say that I start once again from my 3 node, that is the root. I'm just gonna start those things as, oh yeah, I'm thinking about coding. Yeah, I'm gonna put like not found, right? And yeah, not found. Let's say like this. And then I'll go back, I'll go to 5, all right? Exploring. Yeah, this is the 4 and the 5 and 4, yeah.
Okay.
Oh yeah, here I found something, right? But here's the thing. I'm just worried, like, about one thing here. Okay. Because this is gonna return that I found the 5 here. That is like found 5, right? But I mean, when I am in the node. Oh yeah. Okay. Because those 2 founds are gonna be from the left portion and the right portion of the tree.
For 5 and 4, what do you mean left and right portion? Because left is 6 and then right is 7, 2, 4.
No, I mean that this result's gonna represent what I found on my left portion that is the 6, and my right portion that is the 7, 2, and 4.
Mm-hmm.
So if I go on the call stack and find something, I will kind of like, okay, I found on the portion or the right portion. That's what I was thinking. Does that make sense?
So sorry, repeat that.
I was thinking about, okay, have at each level that I'm traversing,
Uh-huh.
right, have this variable, okay, while checking the left part,
Uh-huh.
that is the 6 here,
Uh-huh.
did I found something?
Okay.
No. So it's gonna stay not found.
Okay, good.
And then when I check the right part, that is the 7, 2, and 4,
Uh-huh.
if one of those are like the ones that I'm trying to find,
Mm-hmm.
it's gonna be, yeah, I found in this case the 4, right?
Good. Okay.
Like going back on the recursion stack.
Yep.
Yeah. Okay, so yeah, let me I just put this here. Yeah, not found. But and yeah, I will go to the 4. No, it's not gonna. I'm not. No, yeah, actually, the 2 and the 7. None
Okay.
of those 2 are gonna be the other one I'm trying to find. Then I'll go back on the recursion stack and on the call stack, I mean. And okay, I'll go down. Oops, I found here. And yeah, I will return this, right? Some sort of thing that I found, and it's not found on. I find here, and it's not found on the left part, but was found on the right part. That is, yeah, the 4.
Okay.
And what can I do here is I'm just worrying about this corner case because since this is the node. 5 is one of the nodes that I'm trying to find. Yeah, all right. When I go back to this, okay, I can make this check, like, because this is gonna return that I found this one, right? I found the 4, and when I go back to here, I would say that. Okay. Just one thing. I pointed out this idea of found on the left portion and on the right portion. I think it's like those flags here marking that. Yeah, I found on the left or on the right.
Mhm.
That's doesn't mean nothing. The thing is, if I found my item, let's say A and B, all right, the portion doesn't matter. The node that I found both of them, the one that is the like the lowest common ancestor. Because okay, let's say that this is the 5 I'm trying to find, all right, and this is the 4. All right, I found the 4, and once I'm in the 5, I found it, right? So found it. Both are found. And okay, this is gonna be the lowest common ancestor.
Okay.
So
Mm.
yeah, and
So
then I'll go back
Mm-hmm.
to the call stack. Yeah.
Okay, now to finish up the thought, and then I'll give you my thought.
Oh, okay, yeah. So yeah, this is gonna return that the lowest common ancestor is 5 to this, and yeah, same thing here. So it's gonna return that as the 5. Basically, where the node where I found like both conditions matched, like let's say A and B, right, 2 ancestors, is the one that gonna be like not the 2 ancestors, the two nodes are it's gonna be the lowest common ancestor.
Mm-hmm.
So that's what I'm thinking. Yeah.
Okay. So all right. So cool. I want to point out a few things. You gotta realize, hey, wait a minute. Yeah. It's not always going to be left subtree, right subtree. It might be the node. But what I noticed you were doing is that you are basically using iteration to try and test this idea. But what I was mentioning before is that it doesn't matter if you are iterating left first, right first, or whatever. What matters is this idea of if you found the node in the left subtree or the right subtree in general. Does that make sense?
Yes.
Yes. And so and then if we think about it this way, at 3, wait, let's say we're back at our 5-4 example, right? So and then let's say I'm at node 3. Well, then I found both of these nodes. Well, for one, you're gonna return back to me the node that is the lowest common ancestor. I think you should be explicit about that, as you kind of said it here, but I want you to be explicit. But also that they can both be found in one subtree. So I want you to really make this connection of how this works in the greater scheme of things. So it's about being able to build that connection between the picture of what you're doing visually and this mechanical thing. We're trying to build that knowledge here.
All right.
So next time when you do a problem like this, and I go ahead and do the pseudocode, I want you to do the pseudocode, and when you're doing it, I want you to think about how it plays into this picture. Does that make sense?
Yes, yeah. The thing of found. Sorry, I'm a little bit confusing here. You mean like the thing of found on the left or the right subtree? What does it play on the big picture, right?
Right. It's like I'm saying that. Well, if I were to describe like what you did step by step, like say, okay, I'm gonna do a traversal. I'm gonna look at the left. I'm gonna look at the left node. I'm gonna look at the right node. I'm gonna check to see if I found the nodes that I'm looking for. If I haven't, I'm gonna pass it back up. And that's fine and all, but then the best way I would describe it, like imagine you only had 10 seconds to tell a 5-year-old child what the high level idea is. You should be able to describe that.
All right.
That's the point I want you to get to, and I want you to like think about how to get there. So let's first do the pseudocode, and then I suspect that it'll be a little bit lacking, and then we'll get there. So let's do that first.
All right. So I can start by do a tree reversal, right? So what I was thinking to do is, right, basically do this tree traversal, and once I like find elements that were passing to me as an argument, I will check mark this. So basically, I would like do this traversal and check if the node is a or is one of the ones passed on as an argument.
Mm-hmm.
And mark the respectively, and mark the one respectively.
Okay.
All right. So if was the first. All right, that's it. And okay. And there's another base case in this traversal that I should be aware of is that I guess is basically before. That is, if I am check if in a node that actually this is gonna be do later on, because if I mark one, I'm gonna check it later.
Mm-hmm.
Check if the node that I'm at.
Mm-hmm.
No, check if both nodes were found. Both nodes were found. In this case, I will like the current node is going to be the LCA. Yeah.
Mm-hmm.
And yeah, but beforehand, have to check the left and the right portion of the tree. So I will check, yeah,
Okay.
right,
Okay.
left and right, yeah,
Okay. Yeah. Go ahead.
and right. Yeah. And then if like both of the nodes, both of the values were found,
Mm-hmm.
values I meant, then this is gonna be the current node is gonna be the current LCA.
Okay. Okay. I see.
But I see a test case. Just telling one thing, I see that. How can I fix this? Because simple. If I go 3, 5, I found one. So I'm gonna mark, right? So I'm gonna mark that I found 5, and I will check left and right. And on the right call, it's gonna return that I found a 4. And both, yeah, both values like updated here. I can return because, yeah, both values, yeah. And then if they were found, yeah, this is the current LCA because, yeah, one it's gonna be marked here. I mean, like the 5 value is gonna be marked on the first call, like on this first check, on this first base case. And yeah, and now check left and right. In the right, I'll find the 4, and the 4, yeah, it's gonna return, and both nodes are gonna be like as I mentioned. So
Okay.
this is gonna be the LCA
Okay.
node.
I'm gonna okay. Let's pause there. Okay. Look. So checking the node that's one of the arguments. Mark them one respectively. I'm gonna and this is like me going to. I'm gonna be. It's gonna seem like I'm a little bit pedantic here. I'm like obsessing over like some random nothing details, but these are gonna be important. I'm gonna explain why. So
Okay.
when I say check if one of the nodes passed it as an argument, it should be. Let me add like my text in here, and I'll tell you why. So is equal to the node I'm looking at, right? And then mark that. Let's say mark that one is found. That node as found.
All right.
And then after that, it's like both values, check left and right to see if the nodes are found in those subtrees.
Okay.
The reason, and then like check if both values are found, and then the current, if both values are found, then the current node is going to be the least common ancestor. All right, but then there's a few details that you're missing out here as well, right?
All right. Yeah.
Can you try filling those in?
Oh, the ones ahead, right?
Well, yeah, because like you said, you remember you basically told me that if we found it, we return it, right? So then,
Yes,
can we
yes.
incorporate that into the rest of this definition?
Yeah, I'll try it. Then the current node is going to be the LCA. All right. So yeah, in this case, I will return this. Right, return that LCA node. That LCA node that is the current node.
Mm-hmm.
Current node.
Okay.
I'm at, right?
Okay.
And yeah, I'm just looking for other things that could be wrong. Yeah, and like thinking that if this LCA is returned in one of those two checks that I'm gonna do on left and right, how can I avoid to keep looking for nodes?
Okay, that's one way, but there's another contradiction that you have actually.
All right.
I want you to resolve that contradiction first.
All right. I think the best way is to draw out, like,
Sure.
to see if that idea works.
Mhm.
So
Yep.
yeah, let me just because sometimes thinking is not.
Yep.
Yeah,
Don't do
imagination.
things. Don't do shit in your head, man. I'm gonna tell you that much.
Yeah,
Do
yeah.
not do shit in your head.
You're right. Okay, so 5 and 4. Following my pseudo code. Check. All right. Starting with 3 here. Oh, marked. All right. So starting with the 5. No, with the 3. Oh, sorry. I'll go to the 5. All right. And okay, now 5 falls in this base case. That is one of the nodes that was passed on the argument. And I'll mark the respectively. Let's say that, yeah, 5 found. Found. And okay, now I'll both values check left and right to see if the nodes are found in the subtrees. I'll check 6, right? Actually, it's gonna be with the 5 found here. Then I'll check 6. It's not, and then check if the node. No, it's not like the argument. And then I'll go back to the same condition, but I'll test the 2 right here. And it's not equal, so I will check 7, right? So it's not gonna be equal once again. Then I'll go back on the call stack, and then that is what I'm looking for. That is the 4. Now I found that I am in the 4, right?
Mm-hmm.
And, I found the 5, but this is not gonna go in my call stack anyways. Then I didn't found like the 4 yet here, and I just found the 4 right here, and then this is gonna go back to the call stack here, and then here on like on the 5. So the call stack is going back, and yeah, this. Okay, both values were checked, and after did this, I marked 5 as found and 4 as well, and I'll check if both values were found. That was here, and now this current node is the LCA. Then what I'm gonna do is, yeah, let's say that there's a LCA here. I'm gonna put this as 5, and I will return to 3. But there's one thing. Yeah, I found it.
Okay.
Yeah, I can basically. I think that is the same problem of the other question, actually.
What do you mean?
Like, if I keep doing this, I can just. We're not found. No. I was meaning that. For me, don't check the other portion of the tree. Yeah, so I don't like repeat the error.
I see. I know what you're going at. I'm going to say that's kind of small peanuts compared to what I really want to talk about. But yes, it's kind of the same thing. If you've already found the value, you don't need to check it again. You don't need to continue the traversal.
Yeah.
So, which means that you can just put that right here. But
yeah, in the middle.
Yeah. So what I want to point out, actually, more so, is that, well, you kind of have this check left, check right. But I think based on what you've done, you are marking these as global variables. Is that right?
No, I was. No. The left and right are like the recursion call for the left node and the right node. That's what I mean by this.
Okay, so then you're going to pass in these as arguments. You're going to pass in the node left and node right into it, right?
Yeah.
But then you need to return back this found on the left-hand side and the found on the right-hand side. How are you going to do that?
No, I was thinking to, just be more clear here. Check the left and right side.
Okay. So how are you gonna return that information?
I was thinking maybe to make sort of like, for example, I was thinking to mark then, found a way to mark then
Okay.
found. So when I yeah, that's a question.
Yeah. So that's something that the reason why I noticed that is because well, let's say you say you're gonna return back both values, check left, check right, right? You kind of hand wave that, but more importantly, you have this contradiction here. What's this contradiction? The contradiction is that you say you're gonna return the lowest common ancestor if it's there, but if it's not there, you're gonna return back null. But you also need to return back check left, check right somehow, so which means that you're possibly passing back two flags as well, and then the LCA node. So this is what I mean by the contradiction. This is what I'm saying that is a glaring issue here. That's why I thought, okay, well maybe you're going to use check left, check right as some global flag variable or something like that. But this right here, the way you've written this, there's some contradiction.
What do I mean by passing like left and right? As I mentioned, like is the call to left and right. But I was thinking to like have a sort of a flag of like, all right, so.
Something like this, right? Or node first and then node second.
No, I was thinking about like, okay, this is the node.
Okay.
I was thinking about like. Actually, I was thinking to do a call like this.
Okay.
For example, for the left, and then like A and B. Let's put it like this, and do the same.
Yeah. What I'm saying is I'm giving you the function definition. So let's say that this is a function definition of like node, let's say recurse, and then node, which is a tree, and then node first target, node second.
Oh yeah. That's right.
Yeah. So this is basically what I was expecting you to do, right? But then you promised me that this node was gonna be the LCA. But you see here, like again, the moment I wrote it out, you're like, oh yeah. But then also, where's the left and right come in? So you have two choices: either to bake this into the return type, or make it a global variable that you're gonna evaluate from other parts of the stack. You see how that contradiction just kind of shows up?
Yeah, for sure. Yeah, that
So,
really shows it.
Yeah. So the moment I wrote it out, is like you just kind of like look at it, it's like, oh yeah. So I want you to be able to write, like when you do the recursion problems, I want you to declare like what you expect.
Okay.
Like what is the like? Imagine like you're signing a contract. What are you giving me? What do you expect in return? Right.
All right.
And so this is like where I have a little bit of a problem with like the pseudocode that you've written. It's a little bit wordy. Like let's look at what you wrote. I want to give you an example of like the way I would write it in its full context, right? So I would do this. So that at each traversal, I would say check if the elements are in the left subtree, right subtree, or equal to the node I'm looking at. If I, and then if both are, or if they are found in left subtree and right subtree, then I'm going to say return self as LCA, right? Otherwise, if in left subtree and self, or right subtree and self, return self as LCA. And then otherwise, return, let's say if, or I could say like if LCA in left subtree, return left, right? Return left subtrees LCA. And then same thing for right. If LCA in right subtree, return right subtrees LCA. So this is kind of like the way I would do it. The reason why is because it kind of does resemble code, but more so it's like I'm just checking this. I declare like where I'm checking it, and of course I can be a little bit more clear with like how the traversal actually is run. But you notice here that immediately this one sentence already encapsulates pretty much everything that you're doing here.
Yeah.
You notice how clean that is and how the difference?
Much more. I was maybe like, I did the pseudocode and on the implementation I would realize that, okay, yeah, this contradiction. Should I include like a third parameter?
Mm-hmm.
Yeah, you just made this beforehand. Yeah.
Right. And so it's like, it's a little bit longer, but it's a lot more clear. It's a lot more discreet. So, and of course, like, if you ask me, okay, I want you to break down how you're going to do this, I can do that for you. And so, and this declaration also makes it very clear that I need to make a call to the left, node.left, make a call to node.right, and then just check if the value is equal to node. And then from there, the code just writes itself. So you see, like, just having that very clean setup already gives me a very clean code to write. And if I had to, do the whole elevator pitch of, like, I only have 10 seconds to describe it to a 5-year-old child, I'm going to say, hey, I'm going to look at the left, I'm going to just find my nodes in the left subtree, and the right nodes in the right subtree. And if they are, then I know that the current node I'm looking at is that lowest common ancestor. Otherwise, that lowest common ancestor could be substituted in terms of left subtree or right subtree. So this could be like 5 and 4 or 5 and 6. And in that case, 5 would still be the lowest common ancestor. Otherwise, I must have found the lowest common ancestor in either the left subtree or the right subtree, and I'm going to return that. Or maybe I've never found it at all, in which case I'll return null. Okay, that's a little bit longer than 10 seconds, but you get the gist.
No, but yeah, makes sense.
And I want you to get to that point. I want you to be able to, like, literally do that conceptually, and literally just be able to describe the picture. Like think of yourself as, like, fucking Pablo Picasso or something. Like, you want to be able to paint the picture for the interviewer, because the more visual you can make it, the easier it is for them to understand. Like, this step by step is great, but it's the equivalent of, like, trying to like I said, it's like the walking analogy. Another way you can put it is like a recipe online, like, bake at 450 degrees, use 2 cups of sugar, all that shit. It's like, okay, great, but I don't know what that looks like in the end. All I know is, like, mechanically step by step. But I don't know I don't know the fucking picture. But if you paint me a picture of, like, flowers on a vase, or you picked me a picture of someone cooking, or you did screenshots of even the baking recipe, it's like, oh yeah, I totally understand. Now I know what this looks like.
Okay. Oh yeah. I think you've just addressed, like, one of the biggest points, because I was like, okay, should it be, like, the more detail I can in a pseudocode, or, like, describe the steps? But you already, like, said what I need to do. Mm-hmm. I'll try to implement this. Yeah. Mm-hmm. Thank you for that.
Yeah. So it's the idea of doing more with less. Like, less is more, essentially. That's I think the biggest takeaway I can give you here. And, like, be an artist, not a novel writer. Like, I'm giving you, like, a lot of these analogies, and I'm trying to paint the picture for you, so that way maybe at least one of these analogies actually clicks in your head.
Okay. One question.
Mm-hmm.
Do you think that those, like, steps I put, right? I write it down.
Mm-hmm.
Is it a good, like, way to describe? Yeah, this is gonna be redundant, but I mean, when I first trying to work on my idea and I see that this worked for, like, the edge case, do you think that this is the first step, and then to optimize to a more detailed way as you did here? Do you think that's the way, or should I try to go from my, like, okay, I walk through my example, okay, that's work, let's go and make this, like, as detailed as possible?
Mm-hmm.
Is that what you mean, right?
I would say, if you have a hypothesis, start with the executive summary. And I think that's the easiest way to do it. So, executive summary for hypothesis. And then test it. And then write the step-by-step pseudocode. And then write code. This is basically, I think, this is a template I want to see you do. Of course, with time, you'll be able to eliminate this, and this. But overall, I want you to, like, also, like, draw it out as well. So basically, just follow these 5 steps for now. But over time, like, if you keep doing this, like, diligently, you can eliminate you can eliminate the extra boilerplate for now. Like, afterwards. But for now, just keep this shit in.
Okay.
And I want you, at every single step, I really want you to be thinking to yourself, does this make sense to a 5-year-old child or a golden retriever? Okay, maybe not the golden retriever, but a 5-year-old child at least. Yeah, so the things should be as simple as possible, if not simpler. And this is where, like, being an artist helps. Like, anyone can understand a picture. It's like, oh yeah, that's a picture of an ear, or that's a picture of someone in a garden, or something like that. But you had to start, like, writing a goddamn novel for it, and I was like, no one's gonna give a fuck.
Yeah.
Okay, so we do have 15 minutes left. It's not enough time to do another problem, so I want to actually go over, like, schedule and like sheets and like and all that. Okay. So let's look at practice diary. So I've sent you the link to the diary.
All right.
And I'm kind of want to go over the contents of it with you.
Hold up.
I sent it to you in the Discord.
Yeah, I just sent the.
Do you need
for.
permission for it or?
Yeah, I need a permission.
All right, hold up.
Right.
All right, I adjusted it. Should be good now. Let me know when you see it, and I'll also share my screen in case you can't.
No, I can see perfectly.
Perfect.
I'm on the same page here. Yeah.
Great. So I want you to really like not only just start timing yourself. I also want to like start end when you did it, how difficult it was, the problem. And I think you've seen. I linked the sample page, the sample practice diary in the next page as well. You can see like the level of detail he goes through in order to try and figure out like, hey, this was easy, this was hard, all that shit. Like what he could have done better, what he fucked up on. And I really want you to do the exact same thing. Like really be critical of yourself. Like I spent too much time on this. This step didn't make sense. I could have, if I did this step earlier, I would have been able to actually get done with this problem faster. But right now, I want you to focus more on this idea of making each step simple, discrete, self-contained. And I don't care if it really takes you a little bit longer. But I want you to do it with no mistakes. I want you to do it where you don't go back and say, "Oh, I spent too much time on this shit," or something. I want you to get to a point where you feel like I've spent a reasonable amount of time on each one of these steps without sacrificing safety, and I didn't do anything totally fucking weird.
Yeah. Okay.
So, I want you to do that, and you go ahead.
One thing, for this her comment and thoughts.
Yes.
Do you recommend like to record so I can like rewatch and be critical to myself? Do you think recording is a good tool?
Yes. I think that I want you to do it when you feel like you can and you can do a problem very, very well. That's because I asked you to record every single time you did it. It would be here forever, right? You'd be like basically spending an hour recording, hour watching, and it would take you too long. It's only when you feel like you've done it and you feel comfortable with it, or you feel like you're stuck, then record and watch.
Okay.
Yeah.
So basically, based on my what I wrote down on my notes, like trying to derive the problem, I analyze based on that, right?
Yes. Basically, I like your step-by-step look at it and just like kind of say, oh yeah, fuck, I did this, I did this right, I did this wrong, and all that shit.
Okay. All
right. Now, as far as your study plan goes, let me make a copy. Hold up. And I'll send it to you.
Okay.
And so let me go ahead and clear all this shit out.
I was watching Pablo replay the playlist.
Oh, did I upload? I don't think I uploaded Pavel's playlist actually.
It was like one video of reflection after all the results. And he was saying that on the first problems he would spend like almost more than an hour sometimes. Just like to put quality work instead of like, yeah.
Yep.
Okay, I'll try to do this as well.
Yeah, right. Like the first few problems you do is gonna feel like absolute shit. But the thing is that you learn a lot from those mistakes. Like seriously, like if you learn those mistakes and you learn why you did it and you try to avoid them, the next like after like a week or two, it'll be so easy. You'll take off like a hockey stick. But for now, it's like understanding every single little mistake that you did and understanding why they happen and how you can prevent them from happening in the future. Remember the idea. I want to know where I'm about to die or where I go to die so I can never go there.
Okay.
So,
okay.
I think that analogy really helps. So, let's target the phone screen to be, what's it called? 311. On site, I'm gonna say let's say 4-1.
Hold up, I just opening here. Okay. So you're in this schedule, right?
Yep, I'm writing the schedule down. Okay. So I want you for this coming week 2-5 to 2-11. I want you to do EPI for what's recursion. I want you to practice these ideas for it.
All right. Okay.
And it doesn't necessarily hurt to go a little bit into back into grokking, try it as well. But I really want you to like focus on the recursions thing as well, because I think you're struggling a little bit with being able to visually see it.
Okay.
So I think that's gonna be your biggest thing. Next thing, I want to start making your practice schedule very rigid. So let's do this in your time, which I think is like what Greenwich, not Greenwich. It's 5 hours.
-3. We don't have. It's Brazil Standard Time.
Okay, Brazil Standard Time, sure. So, and that's gonna be like that's plus 5 hours on my time, sure. So I'm gonna let's align this picture here. Okay, so let's see Brazil Standard Time, Pacific. So yeah, Brazil Standard Time, Pacific Standard Time. So let's do this. What time do you usually go to bed?
Same hour as this one.
Sorry, what?
30 minutes. The same one as in this schedule.
Okay, so you go to bed like 1 a.m. and then you wake up at 7:30, or what time do you wake up?
No, yeah, 1 a.m. I wake up at same thing. Basically, I started work at 9. Yeah, I now wake up like 8:45 or something.
Sure.
And I started work at 9. Yeah.
Okay, so the schedule actually works out pretty well for you already.
Yeah, just let me check one thing. Stop for I take like 30 minutes just to eat something. The mid of the day, and actually I stopped work earlier. I stopped work at 6 p.m. right?
Okay, so you stop work at 6 p.m. All right.
Yeah. So 6 p.m. I'm free, and then on the 19th, all right, near 7 p.m.
Okay.
Yeah, no, I think it's pretty good for me. There's no dance on Friday.
Okay, sure. Right. Okay, I'm gonna delete this then. Cool.
Yeah. And since I'm in vacation until April, there's nothing on the way in terms of college or anything else.
Perfect.
So it's basically 100% on this.
Okay, perfect then. Then I know what to do next. I'll fix this Pacific Standard Time a little bit later. So you here, I'm gonna give you after work. I'm gonna give you 30 minutes of break, and then you can eat dinner at 7:30, and then I think keeping this schedule for you is actually fine. This seemed to work pretty well. So this gives us what 1, 2, 3, 4, 5, 6, 7, 8 blocks. So that's 4 hour. What? That's 4 hours of studying per day on the daily, and then on the weekend, I think the schedule works pretty well for you as well.
Pretty much.
Do you have any other obligations or anything else I should be aware of?
No, man. I can put like all my dedication to this.
Cool.
Yeah, and I don't have anything on my schedule.
Great.
I think like last week I'm gonna move to another apartment, so it's gonna be just one day where maybe in the weekend, one portion of the afternoon.
No, that's fine. It's a one-off thing. I'm not gonna mark it. Now as far so then our coaching schedule, this is gonna be 3.
One thing, you said like 4 hours because it's like 1. Oh yeah, 3 and then 1. Okay, in the end. Okay, that makes sense. Sorry, I was just not visualizing.
No problem. 3:30. So then, hold up. Yeah, sorry. Let me finish marking this. Okay, cool.
Do you recommend like on my? I can take 1 hour for lunch break. Do you recommend like some review on lunch break or not like mixed content?
I want you to be I want you, if you feel like you need it, then go ahead, but I would prefer that you just kind of chill, because work's already stressful enough. I don't need you to like compound that unless you feel like you can do it safely. But I mostly don't want my clients to be burning out like really that hard.
Okay.
So then if that's the case, then let's say that since it's like what 6 p.m. your time right now, let's see.
I was just gonna say something on the weekends. All right. Sometimes I just like free time on my morning instead of on the afternoon. I can devote my whole afternoon for study. I did this in the past, so it's not a problem. So I maybe move this like from midday to like 3 p.m. to like the morning. I think. Yeah.
Okay.
What do you think? I don't know.
Sure. If it helps you with like better on with the day, I prefer like in the middle of the day because that way you start the morning with study and then you start really burn down. Like, okay, I need a break, and then after that, yeah, then you're good to go again. That's at least what I think has worked in the past for most people. But it's
I'll try to follow this.
Yeah. Okay, so let me fill this in. Okay. And then as far as like coaching goes, you usually this time for us, we will block out the 11 a.m. for me. So that's wait, why does it say it's 4:30 for you? I might have screwed something up. Whatever, I'll fix it later.
Okay.
Yeah, okay. So this time here is going to be our coaching time from 4 to 6 p.m. I think your time, correct?
Yeah, correct.
Okay, so this will be coaching on Saturday only. Coaching. And then on the weekday, I know it's going to be a little bit early. So, what? It's going to be 8 to 9 p.m. That's going to be like our replay analysis.
Yeah, it's going to be 1 a.m. for me, but that's not a problem. Just one day on the week.
Mm-hmm.
Me, like, sleeping at.
It's a little bit less sleep.
It's not a problem.
Yeah, it's not that big a deal.
Yeah, it's not a problem. Yeah, it's just one day, yeah.
Okay, cool.
I can compensate on my lunchtime anyways.
Okay, yeah. See, 8 p.m. Yeah, that's the earliest I'm available, unfortunately. So, okay, so then let's do this. And then, so we'll do this on Tuesday my time. You've seen the replays with R, so you kind of know what I'm expecting.
Yeah, pretty much.
Good.
Pretty much. And for this one, as you mentioned, yeah, for sure, it's a replay analysis. I should like to record how much of the questions.
I want you to record like 2 questions. That's it.
Okay, 2 questions. Let me take a note. Okay.
Yeah, I'll write that down. 2 questions, replay. And if you run out of problems to do for recursion, let me know, and I will assign you some more. But for now, I think that should be a pretty good load on your plate, especially since if you're doing this right, you should not run out of questions. You should be doing every single question in that book and just at that section and just like, really drilling into your own mistakes. And if you feel like you're getting stuck, ping me, record yourself, and just try to watch that replay as well.
Okay, I will do this.
Okay,
sure.
Cool. Let me see if I missed anything here. No, I think that's it actually. Is there anything else I can help you with?
Eventually on the weekends, because man, that's my #1 priority, right? Eventually, if I don't want to take this free time, can I put one more block here of like 1.5 hours?
Yeah, go ahead. This is only here because I give people the option to, but if you really want to like go hard on this, then feel free to put it in. But I recommend like you do an 1.5 to 2 hour blocks. But you can go harder if you feel like, man, I really want to get this shit done. Feel free to skip the breaks. I'd rather clients feel that way, not because like I tell them to, but of their own volition.
All right. Okay.
Yeah. Let's see. So I will. Do you have a Gmail account so I can because I want to try. I use what's called Google Calendar to try and sync up.
Yeah. That one email that you have .usp, like a Gmail. So if you want to do something on calendar, you can have access as well.
Perfect. I will go ahead and send you all the dates, all the meetings that we're gonna have, and so that way it's gonna be on your calendar, so you don't have an excuse to miss. Yeah, right, I think this is good. I understand. I think you have a lot of work ahead of you, but I think it's all doable within 6 weeks.
All right, man. All right. Thank you very much. Thank you very much for the feedback and for all.
Yeah, for sure, man. Take care, and I'll see you on Tuesday.
You too, man. See you Tuesday.
All right. Bye-bye.
All right.
All right. That was that. A little bit of a rough start, I would say. But it's not necessarily that bad. I think a lot of it's workable, and I think at the end there's the idea of being a little bit more simple and a little bit more, how to say, artistic with his problem solving and simplifying the matter. I think he's gonna help him, and I think he understood the idea. So if there's any questions from the crowd, let me know. Like, I'm here to answer it. If not, then I'll just turn off the stream. But I'll give you guys a few. Yeah, I'm glad you enjoyed it, man. If you have any questions, feel free to toss them out here, and I'll answer them to the best of my ability. Hopefully, you guys learned something as well. Because I think like one of the things that people really kind of forget is that fundamentally we're just problem solving. But at the end of the day, if you can think about these things very, very simply, the problems actually don't become like engineering. They just become like almost like, I would say like storytelling, really. That's the best way to describe it. It's an intense schedule. I don't think it's that intense, actually. If you want to know what my schedule looks like, it's very similar to this, actually. Like, I start work at this time. I stop work at around 5 and then go to the gym. I come back at 7 for dinner. I only spend 30 minutes on dinner. And then between 8 p.m. to 1 a.m., I'm doing exactly the same thing. I'm not studying data structures and algorithms. I'm reading. So, like, I'm spending at least, like, 6 hours a day, like, literally just reading and doing, like, other shit that I want to do. So, I'm looking for... So, you're saying 16th of Microsoft is 16th of February, Microsoft interview for Suite 2. What's your tips on preparing for data structures and algorithms? At this point, you're 2 weeks out. You should already be pretty solid on them. My tips for preparing is to do what's in the guide. And you can find the guide in my Discord channel under resources. And I think I also have the guide posted in the chat as well. So and if you look at the YouTube, the description section, you can see like I post my welcome to the coding interview, you suck. That's there. So if you follow that guide, that's basically what you should have been doing at the beginning. Any tips? Just focus on what you know. Focus on like fixing all the shit you don't know and don't make mistakes. Focus on fixing your mistakes, I would say. It's kind of, you're doing kind of the same thing over and over and over again. It's just doing it at a better level each time. You're looking for your first SWE role at FANG after a short time as a self-taught web dev consultation. How important is system design along with my guide for data structure and algorithms? You don't need system design at an L3 level. So it's not relevant. You need object-oriented programming design. So what do I read? I showed it on my last stream, but I basically read a lot of investment papers. One of them, and a lot of a lot of memos from hedge funds and capital funds. So the one I've been reading most right now is Mark Howard's Oak Tree Capital. There's like essentially 3.5 decades of papers that I'm going through, and I've managed to finish about half of them. So there's like easily there's like 2,400 pages so far. No, it's 1,200 pages. Yeah, 1,200 pages. I've knocked that out in a month. And this shit is just mostly to give me ideas of how I can do better problem solving and how to evaluate the world, and also like fucking what's it called? Like I guess like better manage my own investments. And it just like affects my life in a multiple bunch of ways in a very positive manner. Do I play games or slack of a bit? Yeah, I play like probably 1 or 2 games of Dota per day. Although now it's like a lot less. But yeah, like I'm like at this point where I think I'm like 4 games away from Immortal, and I'm just like I'm so fucking scared to play that I've just kind of like decided to stop playing and just focus on reading. And then now I think I'm pretty sure my skill kind of like dropped a little bit. But like yeah, it's kind of at that point where I'm just like I'm really fucking ladder anxiety or whatever the fuck you call it. I'm just like no, I don't want to play. I'm like on Divine 5 right now. I'm like fuck this. I don't want to do this anymore. Also, like I'm scared I'm gonna hit like some random fucking losing streak and just like fucking trash my MMR, and then I'll just be like even more depressed about playing. What's the main goal I want to achieve this decade? Honestly, I don't really have a goal. Like I just kind of want to learn more about like how things work, and just kind of apply it in a bunch of different ways if I can. So that's kind of like the way I've always operated. It's like just learn one thing really, really, really deeply, and try to understand the nuances, and just try to see what you can do with it. That's it. That's the way I've always operated. So I never really set goals like that. I've never said like, oh, I'm gonna hit like, you know, like I'm gonna hit $100,000 net worth or something like that. I'm gonna make my business a success. I don't see the world like that. I just see the world as like, hey, here's something interesting to learn about. Great. Let me try and explore and learn as much as I can about it. That's it. Like if you told me that someone was gonna teach me all the mechanics of basketball shooting, and he was like a fucking pro player, I'd just be like, shit, I will go out there right now just to like sit and watch him practice shots. And just, as long as I can pick his brain, like, okay, I noticed you did this, like you use like a soft fingertip or a hard fingertip on the release. Why did you do that? Like all that shit. Like, if I could be a fly on the wall on some, like, even for, like, Tim Grover, like, watch him work, that'd be honestly a blessing. Like, just being able to learn about how people work, how things work in the world. That's kind of like the way I've kind of lived my life. So I never really set, like, hard goals like that. If I had the opinion to be a CEO of a fan company, which one would I choose? Another company? Honestly, just Apple. I think that company is fucking amazing. So, I would literally choose to be the CEO of Apple, but I don't think I could do Tim Cook's job at all. That's the problem. I know I don't have the skills to be a CEO, and I probably never will. But, like, it's like if I had the option to, I would definitely want to at least try. I guess with that, like, since there's no other technical questions and stuff, I guess I'll stop the stream for now. I guess this kind of turned more into a personality stream, and I'm kind of like trying to shy away a little bit from that. But well, don't worry, we'll do another stream on Tuesday, 8 p.m. Pacific Standard Time. We're gonna go over his replay, and we're gonna go over hopefully, and maybe at some point during the sessions we'll go over object-oriented programming. But for now, thank you guys for watching. Hopefully, you guys learned something. Follow me on the Discord. Follow me on Twitter. I tweet a lot. I interact with you guys, and I really try to help you guys learn something, improve at your coding interviews. Hopefully, we'll get to see object-oriented programming later on during these sessions. But if you want to watch other coaching sessions, they're all for free, available on my channel. Check that out as well. With that, I'll see you guys later. Have a good afternoon, good evening, good night, and I'll see you guys on Tuesday.